In this phase of our project, we're going to look at how we can add in projectiles. So a good resource for that is going to be in the phaser examples under using bullet groups. So when we look through here, we can see that they've provided some code where we have a bullet class, a bullets class, and then we get to implement that into our project under create. So we're going to be using some of this as a way to make it happen. Now in this particular example here, if we look, it'll fire every time I push the pointer down, but I have, so if we wait till they're all gone, 1, 2, 3, 4, 5, so I can do exactly 5. And part of that is because if we look here, we have a quantity, this frame quantity, the number of items that we're adding that we can shoot. If we change that to a higher number, then we can have more consecutive bullets. So what we're doing is we're making a group of objects, and then that group of objects we're going to then use as a pool so that we don't have unlimited, but we recycle those objects instead of creating new ones every time we fire. So back in our project, I am going to go under my scripts and create a new file. This file will be projectile.js. And now in this file, as we make it, I am going to put a reference to that document, so then I have that as a comment. So if I want to go back to that, I don't have to look as hard to go, where was that? So now I will make my class projectile, and this extends, this time it's going to extend phaser.physics.arcade.sprite. And now within that, we'll have our constructor, which will take in our scene, an X and a Y. And then we call super because we're extending. And I'm also going to, in my super, put in the texture that we are going to be referencing here. Now, I don't have that texture loaded yet, but I know I'm going to give it a reference key of bullet here. So I will put that in. So I do have to hopefully remember to put that in a little bit later when we work with it. So then I'm just going to provide some starting values. These values are fairly meaningless because when we add this to our project, that is where we're going to work with it. So to do this, we'll call fire X, Y, and the direction that we're going to be heading. So one thing that needs to happen when we do this is, unlike in the phaser example where it's only shooting up, we need to change the direction that we are shooting because our player can move in 4 directions. We need to change this in 4 directions. So we tell our body to reset, not rest, reset to the X and Y location. So that now moves it to the player X and Y. And then we need to set active because when we work with these, they're not going to be active when we create them, but instead they won't be active and they won't be visible. Now, we'll notice in this object class, I didn't start out with constructor and then a create or any of that because the creation part happens in its parent group class that we will be writing after we write the individual class here. So this will be set visible, and then and then we send it in the direction that we're heading. Now, to work with that, we'll switch based on that direction. So if we pass in left, this dot set velocity will be -200 left and 0 up, and return. So we can use breaks, we can use returns by exiting out of here. I mean, I know that this is the final thing we're doing, so I can say return. If I used break, if there are more commands in the fire method, then we would want to use break. So, I mean, we can really do either. I'm going to just put in break now. So we have these 4. Now let's go and start moving things back to where they need to be so that it looks a little bit more correct. Whoop, too far. All right, so now if we're going left, right, up, down. So if we're going down, that means we have a positive y value and no x, so it would be 0, 200. And if we're going up, it would be 0x, -200. So then we move up on the screen. And if we're going right, then we're going to be at a positive 200. So that now allows us to fire our projectiles. Now, when a projectile is done so that it has collided with an enemy or collided with a wall, unless we wanted to create projectiles that shoot through things, so if they're ultra powered, you could have a different type of projectile that could actually go through multiple targets until it hits a wall. You could do that as well, but we're not doing that in this project. But if you wanted to, go nuts. And then we'll do our, set active will be false. And this dot set visible will be false. So that now is going to conclude our projectile class for now. And because they're together in this one JS document, I'm also going to include the group class, projectiles extends phaser.physics.arcade.group. And when we're referencing the classes of the phaser library itself, then those classes by convention are going to be capitalized. And then we just pass, or our constructor will call the scene we're working with. Then we call super. And we'll do scene.physics. Oh, and now this physics is going to be lowercase, because this is now the instance, not the class. And then we reference the scene that we're working with. And now in this constructor, we go this dot create multiple, which is a method of groups. So we can create multiple, and frame quantity. In this case, I'll just say 5, and we can choose a variety of options. Key will be bullet, and active will be false, and visible will be false, and the class type will be projectile. So the constructor makes it. Now we're going to, within this group, have a group method, and we'll call the X, Y, and facing parameters will pass into it. So when we call fire projectile, then we're able to get the information from the projectile or from the player. So we'll know what direction the player is facing. So we pass that into it, and then we're going to be able to then determine what direction we want this to go. Now here we can say our projectile is going to be this dot get first dead false. Now this is a sprite method there that when we have groups we're able to work with this, and then we can say if the projectile exists. So this is just a little good check. So if there is a projectile to work with, we'll tell that projectile to fire, and we will pass in X, Y, and facing. Facing is what we end up using here when we fire, where we pass in that direction, and that direction we get from the player that we're working with. Now, so we save that, and back in the index here, let's try again. Don't click on the link, click on what's next to it. Copy, paste twice. This time we'll pass in projectile to it. So now it loads that projectile into our project. So we have that. And then we need to go into our game scene, wander our way up to the top, and we will need to load this asset. So we can pretty much put it anywhere. I'm going to just put it right here and go this.load.image. The image will be key bullet, and the path will be assets bullet slash bullet.png. So that now allows me to load that bullet. Now we had our health bar. Now this time we will add in some projectiles so that we can work with them. So in addition to adding the projectiles, we're going to also want to track or add a key to it. So we're not using cursors here. We'll be using the space bar as part of it. So we will put that in as well. So we have projectiles, we have keys. Now let's go down in our create. So I'll just put another separator to make our code easier to find. And now with this as part of it. So keys, this is the same as what we did inside player, where player is using the different keys of WSAD and the arrow keys. We're also going to now add in spacebar. I mean, probably if our game grows increasingly more complex, we will want to separate keys out so all the key information is happening in a kind of a global area, because it isn't really tied to any one object. We just know that the only kind of thing using it is going to be the player anyway. That's why we put it in the player to separate it out. But we could even put that into its own class and work with that as well. So there's a lot of possibilities. All right, so this now gives us the space key so we can track that. And then I say this dot projectiles is going to be a new projectiles, and we pass in the scene this. And now our projectiles are going to need to collide with the world and collide with the enemies, so we will want to put those in. But first we're going to worry about trying to make them able to fire. Now there's a couple of different ways we can set up timer events. We can set up all these different looping structures. So there's a lot of possible ways that we can handle how do we fire a projectile and work with it inside of our update method. Now if I go down into my update here, we'll see we have time and delta. We're not currently using those yet, but we're going to be using time right now. So time returns the value of milliseconds from when the program started running. Delta returns the time in milliseconds from the last frame or update cycle to the current update cycle. So that's how those end up working. So if this dot keys dot space dot is down, so if we're pressing the space bar, then what we want to do is say this dot projectiles dot fire projectile, and if you notice we're getting the code hinting X, Y, and facing, so it's telling us what it's looking for. So this dot will pass in the player's X, the player's Y, and player facing. So we pass in these values into it. So right now, this should create an interesting result. We'll find out how it works. So I'm right here, and oh, projectile file. Whoops, that would be a typo that we need to address here. So let's see, and that's in the projectile class, not in my game class. Fire. All right, let's save that. Let's try again. And we are getting absolutely nothing occurring just yet. So let's also back in the game scene here just to verify this is working. So every time I'm pressing the key, yep, we are getting some space bar action in there. So let's track this down. So examining the code, realize it auto-populated that with keys when it should have said Y. So if we save this and go here, we can see, all right, it goes, but it's not moving. And now if I go into my projectile code and look here, we can see it's asking for a direction from the player. But what I realize is, in the course of making this, I forgot to put that information in. So with this, we want to set that equal to the direction that the player is facing. Well, the player initially starts out with the facing position of down. So that is the direction we start out with. And now we can see it shot all 5. And they're still going because we don't have any way to deactivate them or claim them back since we are working with a pool of only 5. So, you know, it's a start. But the player is not updating the direction that the player is facing. And we can work with this here. So what we can do as we are trying to figure out inside the player, where the player has its update statement here, what we're going to do is say if, and what's really cool is we have the current animation. So we're able to find out what is the current animation that we are working with here. And we are then able to snag that part of it. And the one we're looking for would be left, right, down, or up. So we can use this method. So we can say if the current animation exists, then we're going to grab that value. Oh wait, I ended up with an extra parenthesis there. Let's try that again. So here we will say facing is going to be equal to, so we're going to find out the current animation and the key of that animation. Now that current animation key would be player left, player right, player up, or player down, so we're able to grab that. But what we want to do is we want to take that key and we want to use a text method where we're able to split a text string, because this is just simply two words hyphenated together. It's a text string. And we're going to look for this hyphen and then use that as a separator between these words. And we're going to then look for the second word. Now, because computers count by 0, so if we wanted the word player, we would look for the word in the first position, which would have the number 0 attached to it. In this case, we want to look for the word in the second position, and because it's an array, we say which item it is. Now, if you are naming, so if you had like ninja-player-right, left, up, or down, then instead of being position 0, 1, 0, or 0, 1, or 2, it would be now 2. But because we only have 2, it's 0, 1. So that's how we're able to get that. So that now gives me that facing value. So if I save this, now go back here and space, and let's rewind, and we can see that it's still not quite working correctly. So we're going to have to deduce out a little bit more on this to make sure it's correct. So just going to use my standard. And now let's refresh our page here. And we're not getting that quite yet. So it looks like my fingers are a little bit slow today. I forgot the T in current. So that's now going to give me that current animation. So now if the player moves to the right, we can see it fired to the right. Now I only get 5 and they're not resetting. So let's refresh. Refresh, hit up, there we go. So we're moving in all 4 directions. So progress has been made. That's good. So we're able to pass in the direction that we're working with it. I think the projectiles, we're going to have to do some rotation on them. But before I do that, I want to work on my projectiles so that these projectiles, one, aren't firing all 5 at the same time, which they're not firing all at the same time, but because 60 frames a second, I press spacebar, it usually kicks off 4 or 5, in one go. That's why we need to update that a little bit. So this is where we're going to implement using time. So I'll ask and say if time. Now, one thing I want to do is I want to add a new variable called last fired time. So I want to do that. So I forgot to do that before I started this. So let's just get rid of this if statement first. So going back up into my preload here, this dot last fired time is, we'll just start it out at 0. So this is the time at which we've fired. So the last time we fired was 0 when our program starts. So now I'm going to compare if the current time is greater than this dot last fired time, which, it starts running. By the time I can press space, time's going to be a positive value, so I'll immediately get to fire. Then I want to set this last fired time equal to the current time plus 500. So what this will do is if I try and press faster than every half second, it won't register because my last fired time will be whatever the current time is plus 500 milliseconds. So by the time I keep press until half a second's elapsed, will my last fired time then be less than the current time. And now we're just going to take this line here, move it up to here. So we only fire when that has happened. So now, if we save this, let's go back over here, and now if I fire, even if I hold down the spacebar too, so it's only going every half second. So that's a much more manageable, but we can see now that we've slowed it down, we need a projectile to rotate. So we'll work on that next. But if you want your firing time to be faster, change that to 100 here, and now we can see where they all fire, but much slower than the initial amount. Now if that's too quick, you could go even slower. So you need to figure out what is the appropriate repeat rate for your firing when you are working on your project. So wandering back into my projectile, what we need to do is not only set its velocity, but we want to set the rotation of this item as well. So that is accomplished by saying this dot body dot rotation, and we rotate based on degrees. So 0 is pointing to the right. That's the orientation of my graphic. So it always starts out at right, or what would be like 3 o'clock on standard analog clock face. So it's pointing to the right. So now if I want to be pointing to the left, it's going to be at 0. Body rotation will be equal to 0 when we're going to the right. And when we are going up, our rotation is going to be equal to -90. So that means we go in a counterclockwise manner, which I mean -90 or 270 both would be the same thing. And then our rotation downward is going to be equal to 90. So let's save that and let's see what it does here. So now we go here and fire left, fire right, fire left, fire up, fire down. Okay, so now we got the firing direction working out. We don't have any collisions going on yet, so this is where we need to start handling that. So currently we can see where we handle player-enemy collision, so it's going to be pretty similar to working with that kind of logic. So we're going to want to collide with the world and collide with it, player and enemy, player enemies. If we go up in here, then we have the player uses a collider with the world layer, so we're going to be using that kind of structure with our projectiles. So this dot physics dot add dot collider, because we don't want to overlap into something, we want when it hits it's done. We'll tell the projectiles and the world layer. And what we do want to do is we want to, because we need the projectiles to be able to reset, this is where we go handle, projectile, world, collision, and then null and this. Okay, so that allows us to collide with the world. So now let's define that out. Handle projectile world collision. We pass in the projectile that we are going to be referencing here. So we use P as part of that. And then with that, we have two options here. One is that we can call the recycle method that is in the particle, or not particle, the projectile. Another option is we can tell the parent of these to kill and hide. I know this sounds really violent, but kill and hide accomplishes two things. It says set active is false, so the object's no longer interacting with the physics world, and then it sets the visible to false, effectively hiding it. And then so both of these lines are accomplishing the same thing. So if we want to handle the recycling inside the class itself, so we're doing something with the object, we would use that. If we just are going to let the parent group handle it, we can use kill and hide. But kill and hide does exactly the same two commands here, which is set active and set visible, turns them both to false. It doesn't remove it from memory. It doesn't remove it out of the game. It just sets active, so it's no longer engaging the physics, and it's no longer visible for anybody to see. So now, if we go back to our game here, I've hit fire a whole bunch of times, 10 times. I get to keep going. And we can see how now I'm hitting it really fast, but I'm limited in my timing to every half second. If that's too slow and you want to change your fire repeat rate to a faster amount, you do that inside the update by changing that amount. Now, you could set it as a variable instead of having the number buried in update, and that's a good programming practice. So all these numbers that we're working with all exist inside our preload and create where we populate them. That would be another way to work with it. All right. So we have our projectiles hitting the walls. Let's make our projectiles hit the enemies. Nope, I'm in the wrong part of my code there. I was wondering why I'm like overlaps. No. So this .physics.add.overlap, because we want our object to overlap into it, and it will be this .projectiles. And this time, instead of the projectiles, what we're going to be doing is this, instead of the world layer, we'll pass in the array of enemies that we're working with. And then we'll have a projectile enemy collision function. As you can see, pretty similar code here to what we're doing with that. So projectile enemy collisions, as we are passing those in. And the two parameters will be our enemy and our projectile. And we want it to be in that order. So if the projectile is active, so we want to verify it is currently active. And we do this as kind of error checking, because otherwise if we ask for things that aren't active and we try and do these active activities on them, then our program could potentially crash. So what I want to do, so right now, if it's active, then we can just say enemy explode and projectile recycle. So let's save this and see what happens. Okay, it goes away, boom. Yeah, that's not really satisfying. They just disappear, and it kind of disappears in a pretty big chunk. What I'd rather see happen is, watch the enemy maybe turn a color. So, red is usually our danger color, so we'll make them turn red. But then I want to delay for just a moment before I make them explode and recycle. So I'm going to just set a little time callback here. So first, we'll set the tint of our enemy to red. Then I want to add this time event. And this time event just slows it down a little bit more so we can see what's happening. And this is where we do it. We say how long we want the slowdown to be. Now we could use a set timeout event or something like that, a native JavaScript event, but because we're in Phaser and there's the time events we can work with in Phaser, it kind of makes sense just to use the native events that are built into it. So this is where it's going to take some experimentation to figure out how many milliseconds. So you want it, if it's too slow, the projectile is going to go through the enemy and into maybe even the next enemy after that. And if it's too fast, we don't get to see anything happen. So it really does require some experimentation to figure it out. So the callback, we could write out a separate method, but it's just as easy in this case to use an anonymous function. And this is where we'll call our enemy explode and our particle, not particle, our projectile. I was thinking ahead of myself. And we tell the projectile to recycle. Then after this callback, comma, then we have to say the callback scope, and it will be this. And we don't want this timer event to loop, we just want it to go one time. So let's save this. Oh, and we don't need those there anymore. I'll just comment them for now, save it, and now let's see. Of course, when you want to hit one, it's okay. We saw it turn red and kind of disappear, so that seems to be a better approach. Now, if I were to change this up to, say, 90, we can see where it goes through them. They turn red. We could see that longer, but then after it's gone through them, it's all the way past them before it goes away. So I prefer to do it like that. So now we have projectiles. They're rotating to the direction that we're shooting them. They are hitting the enemies. The enemies in projectile are kind of exploding, recycling. And we have some additional visual feedback to make the whole thing just feel a little bit better.